નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Today in standard 10th subject mathematics we are going to learn chapter 13 surface area and volume. In exercise 13.2 of this chapter surface area and volume, here in this exercise volume of combination of solids. First question, a solid is in the shape of a cone standing on a hemisphere. Here there is a hemisphere and cone is standing on this hemisphere with both their radii being equal to 1 centimeter. Here both radius of the cone as well as radius of the hemisphere 1 centimeter, and the height of the cone is equal to its radius. So height of the cone is also equal to its radius, that is 1 centimeter. So here radius and the height both 1 centimeter. Find the volume of the solid in terms of pi. So here we will keep pi as it is. So first of all, here radius of cone is equal to radius of hemisphere, and that is 1 centimeter. The height is also equal to radius, and therefore height of cone is equal to its radius, and that is 1 centimeter. So here we have to find therefore volume of the solid. Volume of the solid is equal to volume of, here hemisphere is there and cone is also there. So volume of hemisphere plus volume of cone. Both the volume together gives us the volume of the solid. Now volume of hemisphere is 2 by 3 pi r cube plus volume of cone is here 1/3 of the volume of cylinder, that is 1 by 3 pi r square h. So here you can see 1 by 3 is common, here 2 by 3, here 1 by 3, pi also common, r square also common. So 1 by 3 pi r square common. So here 2 left and r plus here 1 by 3 pi r square common, so h. Substituting the value 1 by 3 pi we have to keep as it is. In terms of pi we want radius is 1, so 1 square multiplied by, in bracket here 2 times radius plus height. So that is 1 by 3 into pi into 1 into here 2 and 2 plus 1, that is 3. As here 3 cut common, and thus we get pi into 1, that is pi centimeter cube. As it is volume, it is centimeter cube. So pi centimeter cube is the volume of the solid. Now next question is here. Engineering student was asked to make a model shaped like a cylinder. Model is shaped like cylinder with 2 cones. Cylinder is there, here you can see, and with 2 cones attached at its ends using thin aluminum sheet. Thin aluminum sheet was used to have the 2 conical ends. The diameter of the model is 3 centimeter. Diameter of the model is 3 centimeter. That is radius is 1.5 centimeter, and its length is 12 centimeter. Length is 12 centimeter. Each cone has the height of each cone. Here the height of the cone 2 centimeter. Here height of the cone is 2 centimeter. Then find the volume of air contained in this model that was made. So let us find the air contained in it. So for that, first of all, we will go for the dimensions here. First, height of the cone. Height of cone. Here we say h is equal to 2 centimeter given. Height of the cone. Okay. Each cone has a height 2 centimeter. Now total length. So total length is 12 centimeter, but height of the cone 2 centimeter, two cones are there. So here we will get height of cylindrical part, say capital H, and that is total height 12 minus 2 times 2 cone, 2 centimeter here and 2 centimeter here, and that is 12 minus 4, and that is 8 centimeter. And the radius for both is same. Radius of cone as well as hemisphere is here diameter divided by 2, so 3 by 2 centimeter. And therefore now our question is to find the air contained in the model, the volume of air contained in the model. Therefore volume of air contained in the model is equal to here. First of all, the volume of cylinder and volume of two cones. So here volume of cylinder plus there are two cones at each end. So 2 times the volume of conical ends. So here volume of cylinder is pi r square h, and here 2 times the volume of cone is 1 by 3 pi r square. Here height is small h for the cone. Here you can see now what is common? Pi r square is common. So pi r square common. So here we will get h left and plus here 2 by 3 small h. 2 by 3 small h. Now we will substitute the value. Here you can see we are substituting the value. Pi is we have to take 22 by 7. Radius r square, and the radius is 3 by 2. So here 3 by 2 multiplied by 3 by 2 multiplied by in bracket height. Height is, here you can say height of the cylinder is 8 centimeter. This is height of the cylinder 8 centimeter plus 2 by 3 times the height, small height, and that is conic height of the cone 2 centimeter. So here we got this. So now we can write here that is equal to 22 by 7 multiplied by 3 by 2 multiplied by 3 by 2. Now in bracket multiplied by 8 plus, here you can say 2 2s are 4 by 3. Taking LCM, it is 8 by 1, that is 3 LCM. So 8 3s are 24 plus 4, that is 28 by 3. So on calculation, here 22 by 7 multiplied by 3 by 2 multiplied by 3 by 2. Here taking LCM 8 1, here 8 by 1, 1 3s are 3, 8 3s are 24 plus 4, that is 28 by 3. Cut the common ones, here 3 3 cut, here 7 1 ja, here 7 4 ja, here 4 1 ja, and here 2 2s are 4. So here numerator is left 22 into 3, and that is 66, and denominator is 1, and so this is 66 centimeter cube. It is the volume of air contained in this model made by a student. In question number 3, there is a gulab jamun contains sugar syrup up to about 30% of its volume. So total volume of the gulab jamun is there, in that 30% is sugar syrup. Find approximately how much sugar syrup would be found in 45 gulab jamuns. Total 45 gulab jamuns are there, and each gulab jamun here 30% of sugar syrup is there. So how much sugar syrup is there in these 45 gulab jamuns, where the gulab jamuns are shaped like a cylinder with hemispherical ends with length 5 centimeter. Length of the gulab jamun 5 centimeter and its diameter is 2.8 centimeter. So total length is 5 centimeter but diameter is 2.8. So radius is 1.4 centimeter. This is the radius, and here radius, this radius. So this is 1.4 centimeter here, 1.4 centimeter. Here also it is 1.4 centimeter, this much portion. And so this length, cylindrical length is 5 centimeter minus 1.4 minus 1.4. So that is 2.2 centimeter. So that is the height of the cylinder, radius of both the same. So here let us write the dimensions. As here the gulab jamun with the two hemispherical ends, so radius is subtracted, then we will get the height. Here total height of gulab jamun is 5 centimeter. So and the radius is equal to, diameter is here given 2.8 divided by 2. Diameter is 2.8 and that is 1.4 centimeter is the radius. Therefore, height of cylindrical part, and that is h, and that is equal to here. How much it is? That is height of cylindrical part h is equal to 5 centimeter minus 2 times 1.4. 1.4 in 1.4. So 2 times 1.4, that is 5 minus 2.8, and that is 2.2 centimeter. It is the length of this height of this cylindrical part, we can say. So these are the dimensions. Now our question is, first of all we have to find the volume of 45 gulab jamuns, and then we have to find out the sugar syrup, and that is 30% of the total volume. So first of all, now therefore volume of 45 gulab jamuns is equal to 45 multiplied by volume of cylinder plus 2 hemispheres, 2 times the volume of hemispherical ends. So that is equal to 45 multiplied by, in bracket, volume of cylinder. Formula for the cylinder is 2 pi r square h, plus here 2 times the volume of hemisphere. So formula for the volume of hemisphere is 2 by 3 pi r cube, but there are 2 hemispheres, so 2 multiplied by. So thus we will get here 45 multiplied by, in bracket, you can see here we can take pi r square common. So pi r square common. So now in bracket what is left? Height, plus another bracket pi r square common. So 2 2s are 4 by 3 r. So now substituting the value 45 multiplied by 22 by 7 multiplied by radius. Now radius is here 1.4, and that is, we say 14 by 10 as it is square, multiplied by, in bracket, height. Now here you can see the height is 2.2 centimeter height, and so we say 2.2, that is 22 by 10, plus 4 by 3 multiplied by radius. Radius is 1.4, that is we say 14 by 10. In decimals also we can write, and I have converted into fraction. 45 multiplied by 22 by 7 multiplied by 14 by 10 multiplied by 14 by 10, in bracket. Here you can see, here it is LCM is 30, so here denominator 30, and here it is 3s are 22 3s are, plus here 14 4s are 56. So cut the common ones. Here 7 1 ja, here 2 5s are, then here 5 9 ja. Now 9 multiplied by 22 multiplied by 14, we are not cutting 2 because 5 we can't cut, let it be in decimal. Multiplied by, here it is 66 plus 56, and that is 122 divided by 30. So cut the common ones. Here 3 10 ja, here 3 3s are. So here we will get 3 multiplied by 22. 3 multiplied by 22 multiplied by 14 multiplied by 122 divided by 100. So here when we multiply them, we will get here 112728 divided by 100, and therefore two decimal places, so 1127.28 centimeter cube. This is what is the volume of 45 gulab jamun. But our question is to find volume of sugar syrup, and that is 30%. Okay, so here therefore the volume, finally the volume of sugar syrup in 45 gulab jamun in 45 gulab jamuns, here sugar syrup is equal to 30% of volume, that is 1127.28 centimeter cube. So that is here 30% of the total volume of 45 gulab jamuns. Volume of sugar syrup is 30% of the total volume of 45 gulab jamuns, and that is 30%, that is 30 by 100 multiplied by 112728 divided by 100. Cut the common ones, 0 0 cut, and thus we get 3 multiplied by 112728, and thus we will get on multiplying 338 184 divided by 1000. So in decimal places when we write, we get here 338.184 centimeter cube, and that is equal to 338 centimeter cube is approximate volume of sugar syrup, that is 30% sugar syrup in 45 gulab jamuns, and that is 30% of the sugar syrup here is 338 centimeter cube. Thank you for joining us.